In last lecture we have seen what is linked list, its comparison and the memory representation. In today's section we will see operations on linked list. So the operations on linked list are traversing the linked list, searching the linked list in unsorted and sorted array, insertion of node at the beginning, at the end and in between, because we know linked list is having head node, null pointer. Display of linked list as our linked list is created, how it is displayed. Deletion of node is also done by these three things, that is from the beginning, from the end and in between the list. So starting with traversing a linked list. So the best example of traversing is nothing but whenever we used to travel in between the cities, we used to stop, we used to visit at each and every stop, and that is nothing but visiting that node, and visiting that node is nothing but traversing the node. So linked list is nothing but the collection of elements we know. So when we are traversing the linked list, we are visiting each and every node of the linked list, starting from the head node till the null pointer. So start pointing the first node till our null will be reached. So that will be the traversing. So now how the traversing is done? When we are traversing, we will start from the head node and we will visit the next pointer. After visiting the next node, we will increment our pointer and again we will visit to next node till our null pointer comes. That is nothing but traversing of the linked list. So now the next thing is searching of linked list. Now if the question can be asked that write a procedure for searching a particular node in the linked list. Now it can be done by two ways, when the list is sorted and when the list is unsorted. So if the list is linked list in a memory and suppose item or information is given which we want to search, then if the list is unsorted, that means the list is not sorted, then we will search the item by traversing the linked list. Means we will compare the element with each and every node and then the searching has been done one by one, and we will update the pointer to the next pointer if the element is not received. So this process will be done until the element is searched or until the null pointer is searched. And if the list is sorted, then we will start our pointer from the head node, then we will compare the item with the data node. If the item is greater than the data node, then our pointer will be moved to next node for searching the element. This has been done if the list is in the sorted format. Now if we want to insert the new node in the linked list, so when we are creating our linked list, we know the dynamic memory size is used because it's not in the fixed length size. So whenever we want to insert the node in the linked list, it will be the first node, and we know that in linked list the first node is nothing but the head node. So suppose we want to add the first node in the linked list, then the present head node will be moved to the node which is added now, and the head will be given to the added one. Suppose we are having linked list as 10, 15, 20, 25 and we want to add 5, then the linked list becomes 5, 10, 15, 20 and 25. Otherwise, we will take this particular example. Now we are having A, B, C, D as the linked list. A is your head node because it is starting point, but we want to insert E node at the starting. So the head node will be moved to the node E, and A will be the next node to the head node E. So in this way we have added the node E and the head node is given to E. Then our linked list becomes E, A, B, C, D, where E is your head node and D is having the null pointer. This is how the node is inserted at the beginning. Now suppose we want to add the node in the end, means we are having list as 5, 10, 15, 20, 25 and we want to add 30. So our list becomes 5, 10, 15, 20, 25 and 30. Now as we know, the last node contains the null pointer. So as we can see over here, we want to insert the element E at the end. So as D was the last node, the null pointer is given to E pointer. So we are having the new linked list as A, B, C, D, E, where E is having the null pointer. So this is how we used to add the element at the end. When we want to add the element in between, it is the simple process. We want to add E, it will be simply added in between B and C. So the list becomes A, B, E, C, D. So this was how we can insert the element. Now in the same way we can delete the element. That means we can delete the element at the beginning, at the end, and at the in between the thing. Now this is the particular example we are having. Now A is having head node and D is having null pointer, and if we want to delete the element C, which is in between the node, so we will simply delete the C node and the linked list becomes A, B and D. But suppose we want to delete the element A, which is at the first side, so A will be deleted and your head will be given to node B. Same way, if we want to delete the element D, then D will be deleted and null pointer will be given to C. In this way, the deletion has been done at the beginning, at the end, and in between the list. So this is nothing but the deletion operation, which can be done in 3 ways. So these were the operations which we have seen today, that is insertion, deletion, and traversing, searching in sorted and unsorted way in the linked list. In next session, we will see the doubly linked list and operations on it.